material. You just take the help of friends and ask them to send about the scanned images of a particular questions given. You people have to do. That's it. So yesterday I told to finish from page number 193 onwards, question number 10 to 29. I gave a work. So let us see how many people completed that. Say yes if you did it. So only one person. Great. Only 2, 3. Nice. So if you have doubts in that, you can ask me now. If you have doubts in the questions, you people can ask. May I stop?
Sir, yes, sir. Page number 193, 11th question, sir. That I didn't do that only once, sir.
93, question number?
193, question number 11, sir. The ratios of the gap, for the gap, that one, sir.
Ratio of gap, man, distance gap, man. So n1 square, n2 square, n3 square, n4 square. So what is the first gap? n2 square minus n1 square.
Okay. Means the answer will be C, no, sir?
D.
1, D.
N square. N2 square means what? 4. Minus 1. 4 minus 1 gap.
3.
How much?
3.
Next, 9 minus 4 gap.
5. Okay, sir. Understood, sir. Thank you, sir.
Right. Any more? Mr. Rahul?
Sir, sixth one, sir.
Yes?
This one only, sir. Sixth one I didn't got, sir.
So, you understood?
Sixth one, sir.
Which page?
This only, sir. The de Broglie which you have displayed on.
I am asking
Screen,
about
sir.
these questions, man.
No, sir. I don't have material, sir. I am asking, sir, my friend.
So I am asking about the work assigned, and you are asking about the displayed questions, right? Okay. So I already said you that clearly. There is no question of no materials. You people have to get at least from your friends and such that you have to complete the given work. That is final. And let us go for this question. Some people said it is no, they didn't get it. Mr. Abhigyan.
Yes, sir. Sir, I'm having doubt in 10th and 13th one, sir.
Which number?
193 and 194.
Which number?
10 and 13.
What they give hypothetical hydrogen like atom. Text lines are given. Found that line E belongs to visible. Line E belongs to visible means it should be Balmer series.
Yes, sir.
So Balmer series means N2 minus N1 energy gap is in visible region.
Yes, sir.
The lines possibly belong to, then the lines possibly belongs to ultraviolet region with E. Which lines belong to ultraviolet, which are having lower energy?
Yes, sir.
Belongs to visible, then automatically, so A also more than energy. Which have more energy than E, which have more energy than E. Those belongs to ultraviolet, okay?
Okay, sir.
So than E, which has more energy, undoubtedly A.
Yes, sir.
How do you say it is A? Because N4 to N1.
Yes, sir. Gap is 3.
Not gap. N4 to N. See, 2 to 1 energy gap 10.2. 2 to
Yes,
1
sir.
energy gap 10.2. Do you remember?
Yes, sir. Yes, sir.
And 4 to 1 energy gap is more than 10.2.
Yes, sir.
A is undoubtedly. And remaining identify B or C or D. That might not be possible.
Yes, sir.
A only you can.
Yes, sir.
Next 13th one, yesterday class I told you already, your model.
Yes, sir. I'm doing it in the same way, sir. I'm taking 1 mole equal to
Avogadro
6.
number.
Yes, sir. Avogadro number.
In that Avogadro number, 50% were in which state? Third level.
Right.
Means how many atoms? 3 into 10 power 23. Okay.
Yes, sir.
So 3 into 10 power 23 are in third energy level of helium ion.
Yes, sir.
When they are coming to ground state, means third orbit to first orbit, what is energy liberated? E3 minus E1 for He plus.
Yes, sir.
And that into multiply with 3 into 10 power 23.
Yes, sir. Why we will multiply with 3 into 10 to the power 23?
E3 to E1, only one atom you are taking, man, but you have 3 into 10 power 23 atoms, right?
Oh, okay, sir.
So that is first part. Next, similarly, 25% in second level.
1.5.
They are coming from 2 to 1. Calculate the value. Sum of them total.
Yes, sir. Understood, sir.
Next. So let us go for the question number 6. De Broglie wavelength of electron in He plus. So Srihit,
Sir, question number 24, sir. Page 178.
1.
78.
I told you to give 193. I told you to practice, and you are asking about 178.
Day before yesterday, sir.
Okay. Angular momentum, man. I already gave you the explanation also. Okay. What is angular momentum formula? MVR is equal to
Equal
J.
to NH by 2.
MVR is equal to J. Okay.
Yes, sir.
What is the kinetic energy formula? Half
Half kz square by r.
mv square, man.
Yes, sir.
Now, so square m and r square by mr square also we write or not?
Yes, sir.
You understand that?
Understood, sir.
Now, m square v square r square, what we write here?
J.
Square. J square, okay?
Yes, sir.
Then what is the formula will become now? Half j square by mr square. See once. First option only, man.
Yes, sir. J square by 2 mr square.
Understood that?
Yes, sir.
Next. So when you see that question number 80, question number 6 given here, de Broglie wavelength of electron in He plus is given. Means identify the electron is in which orbit to have the de Broglie wavelength. So what is electron presence orbit identify? Electron is present in which orbit identify? Or at least calculate energy. At least calculate energy. Lambda is equal to h by root over 2m ke. So calculate kinetic energy for this wavelength. So when the electron comes to that ground level, what is the ground level energy level of hydro He plus z square by n square of 13.6? So find the difference, and the difference energy is given to hydrogen atom. Difference energy is given to hydrogen atom. Okay. 1 second. Now see the question here. What is de Broglie wavelength given? 3.32 angstroms. What method show?
Sir, I think the answer is 2.348 Armstrong, sir.
Okay.
After calculations in your method only, I got this answer, sir.
Okay.
Thank you, sir.
Right. So this I can give you in various methods. So lambda is equal to h by root over 2 mke we can use. And if you people feel that comfortable way, I'm saying that. So 2 pi r is equal to n lambda. We also know that 2 pi r should be equal to n lambda. So 2 pi r means we know n square by z of 0.529 is equal to n of lambda. N of lambda. Directly I want to estimate the electron is in which orbit. Electron is in which orbit. So n cancel. So from this what we have here 2 pi n by z value is 2 for helium. 0.529 is equal to 3.32. Both are in angstroms. Both are in angstroms. Okay. And from this 2 cancelled, you know, n is equal to we want to get. So 3.32 by 0.529 into 1 by pi also we need to write. So what is 3.32? 32 by 0.529 divided by 3.14, approximately what we get 2. So n is equal to 2. So second orbit it is. This second orbit electron coming to first orbit, what is energy liberated? Energy liberated when electron comes to first orbit from second orbit of He plus E's. That is nothing but E2 minus E1. Nothing but E2 minus E1. Okay. So what is E2 minus E1? We have so 13.6 of z square by n square. So z square is 4. N square also 4 here. So this value is 13.6 plus. This is minus. Or you can find the energy gap, no problem. E1. So 4 into 13.6. 4 into 13.6 means 3 times of 13.6 you need to write. 3 times of 13.6 you write means what we write 39 plus 1.8, 40.8 electron volts. 40.8 electron volts. That is the energy supplied. Now, when this energy is supplied to hydrogen atom, when this energy is supplied to hydrogen atom, so 40.8 electron volts is given to hydrogen atom. So H nu is equal to H, what we say that pi plus kinetic energy. So pi is work function for hydrogen, that is 13.6 plus kinetic energy of the photoelectron. So if you know kinetic energy of the photoelectron is, so 40.8 minus 13.6, that is how much we write now, 26 point or 27. So 27.2 we write. 27.2 electron volts. Then what is lambda of this electron? H by root over 2 MeV or 2 MKE. So that you need to find out. Or directly you can use what as it is electron. As it is electron, So 12.27 by root over V angstroms. So 12.27 by root over 27.2 angstroms. If kinetic energy is in electron volts, directly you can assume that. .21. That is 2.355 angstroms. Angstroms. So identify the answer then. So 2.355, which is nearest we have A. That is the answer. So see the problem as it is different model definitely, and you people follow that carefully. And whatever the method you do, the same answer you should get. So you people understood the question? The question is very good question, very good, advanced level. So note down the question, all of you. This question number 6 into classwork. Note down that and do that. So if all of you have practiced this question, then I will go for the next part. As we are having enough time, no problem, as the weekend syllabus is over already. So slowly we will move on. Next, so let us move on to the next part, that is Heisenberg uncertainty principle. Heisenberg uncertainty principle. So, as per Niels Bohr, when electron is revolving around the nucleus in the well-defined circular path, So if electron is traveling in the well-defined path, it is easy to identify the electron. It is easy to locate the electron. And if you find the location of electron and in the first orbit, its velocity is constant, and so that we can find the momentum of electron also. So as per Bohr, it is possible to find the position and the momentum of electron. As per Bohr, it is possible to find position and momentum of an electron in the particular orbit. But Heisenberg uncertainty principle overruled the concept of stationary orbits, the concept of well-defined orbits. Heisenberg's uncertainty principle overruled the existence of the well-defined circular orbits as per Bohr. The meaning I'm saying that uncertainty means exactness. So if you are able to find the position, well-defined position, suppose if you every day and every minute and every moment, 24 hours a day, if you are sitting in the same position of your home, so that your position is well-defined, certain. But sometimes if you are in bedroom, and sometimes if you are in balcony, sometimes if you are in dining room, sometimes if you are on the street, so then the position is not certain. Position becomes uncertain with respect to time. Position becomes uncertain. Means to what area? So you are not saying the exact point where you are fine, just where you are placed. You are not saying the well-defined point. And if the 24 hours a day and the whole day, if you are stationary at the same position at the same point, then your position is certain, just like a fan. The position of the fan in the home is always certain because it's always ceiling fan if you take, not the table fan. Ceiling fan position is always fixed. But as we, the human beings, and as we know, the toys and the human beings cannot be stationary always. They're always moving and dislocated sometimes. So when they are going on for changing their positions, so then what is the uncertainty? Means what is the chances to find the particular person in home? Nothing but the total cross-sectional area of home we will take. If you just take the home as a circle, so we can say somewhere we will be there in the home, somewhere we will be identified in the circle. Understood? So we are making a boundary. So from where to where we can be identified, where to where we are present. So that is what we call uncertainty. Uncertainty. Certain means exactness. Uncertain means somewhat ambiguity is there in your position. So to some extent it will be, we are saying. And it's a common experience to every student when you are trying to share your location to your friends or relatives through WhatsApp via Google Maps. So when you are trying to share your location, it is showing that location accurate up to 20 meters or 40 meters or 65 meters or 100 meters, or sometimes based on the strength of the signal, it might show 1000 meters also. Means the meaning is accurate up to 1000 meters means around the point. If you just draw the 1000 meters circle, diameter, 1000 meters as a diameter, if you just draw the circle, so within that vicinity, your position may be somewhere. That is the meaning. So the uncertainty in the position will be now 1000 meters. Uncertainty in your position is 1000 meters as per Google Maps. If it is saying that accurate up to 20 meters, means around your position, if you just imagine 20-meter diameter, and if you just draw the circle, so within the 20-meter boundary, your position will be fixed. Your position is identified. That is what exactly uncertainty saying that. Uncertainty means inexactness when we are unable to trace out the exact well-defined position, then we are going for uncertainty. With error, we can say, within some boundaries, we can say. Within the boundaries, we can say. As per Bohr, it is possible to find out exact position and momentum of an electron, but Heisenberg completely overruled that. As per Heisenberg principle, it is impossible to find both position and momentum of microscopic particles. It is impossible to find both position and momentum of microscopic particles like electrons simultaneously and accurately. For human beings, we can find momentum, but position uncertain because we might be here or there somewhere. Likewise, but human beings means as macro objects, no problem. We can exclude the concept. Heisenberg uncertainty principle is applicable for both micro and macro, but significantly de Broglie concept, Heisenberg concept are applicable, well applicable for microparticles. Well applicable for microparticles. So it is impossible to measure both position and momentum of microscopic particle like electrons simultaneously and accurately. Okay. So that is a basic idea. Then what is the problem exactly? What is the problem? Why we can't find both at a time? So I'm giving the clarity then. If you want to see any object, the condition is what? Light should fall on it. Light should fall on it, and the light fallen on the object should be reflected back and reaches our eye. Then the brain creates a sensation of vision. Sensation of vision. Okay, so the light should fall on the object and the light should be reflected back, and the reflected light should reach the eye, and then eyes will create the sensation of vision here. This is the idea. And to visualize any object, condition is size of the object should be larger than generally larger than the wavelength of light. Size of the object is larger than the wavelength of light, undoubtedly. Now, as electron is a small particle. So to see that, you should use radiation, least wavelength radiation to see the electron, to visualize the electron, to visualize the electron. right? Next. So if the size of electron is very small, so undoubtedly what we see that to see the electron as it is very small and to visualize we should use light of lowest wavelength. So when you are using the light of lowest wavelength means energy of the photon is increasing. Energy of the photon is increasing. Okay. So to see the electron, compulsory you should use the lowest wavelength photon. And whenever you are taking that lowest wavelength photon, it should have highest energy. As high energetic photon collides the electron, there are two possibilities will happen. There are two possibilities. First possibility, as it is more energetic, as it is more energetic. So we can say that the more energetic photon is absorbed by electron and can jump out of the atom. Purpose is you are focusing the torchlight to see electron. But you know, torchlight, you are getting light is a form of energy, and the form of energy is it accepted by electron and can jump over the place, and it is not there to see. It is not available there to see, to visualize. So electron's position is misplaced. So electron can't be identified exactly there. So it is maybe in some boundary we can say. And there is another possibility. Another possibility is assume that the electron is not absorbing the photon. Case 1, electron is absorbing photon completely and jumping out. Case 2, assume electron is not absorbing that. And so the fast moving photon can collide the electron. Fast moving photon can collide the electron. And because of the moment, or because of the collision, the momentum and position of electron will change as per Compton effect. As per Compton effect, the momentum and the position of electron momentarily changes. So then also position of electron is uncertain, momentum of electron is uncertain. So in either case, position and momentum becomes uncertain and we cannot calculate the values accurately. We cannot calculate the values accurately. This is a problem. right? So the photon can collide the electron, and electron's momentum and position changes at a time. So you cannot find exactly where the electron is or what is the momentum of electron is. You cannot find that. That's why Heisenberg uncertainty principle clearly mentioned it is impossible to find both at a time. Now, let us go for the mathematical part of the Heisenberg principle. Consider, as just now we told that electron's position is uncertain. Position is uncertain means I already told you a best example. If you are in home, so at somewhere you will be there. So home, if you just draw that as a circle, that is your uncertainty in position. So I am taking that uncertainty in position of electron is delta x, or microscopic particle delta x, and delta p is uncertainty in the momentum. You know, momentum is product of mass and velocity. So delta p is equal to m delta v also we can use. M delta v also we can use. Delta x is nothing but uncertainty in position, and delta v is nothing but uncertainty in velocity, and delta p is uncertainty in momentum. Uncertainty in momentum. Next, as delta p is uncertainty in momentum, and mathematically we can mention the product of uncertainties should always be more than or equal to h by 4 pi. Delta x into delta p greater than or equal to h by 4 pi. And in the place of delta p, we can write m delta v, and then delta x into delta v greater than or equal to h by 4 pi m. So by any means, if you try to calculate the uncertainties, the product of uncertainties should not be less than a minimum value. Product of uncertainties should not be less than certain minimum value, that is h by 4 pi. So delta x into delta p greater than or equal to h by 4 pi. Okay, now, so keep in mind that if delta x is 0 means your uncertainty is 0 means your position is well defined and fixed throughout. So position is certain. If position is certain, then delta p will become infinity. So one is certain means other will become infinity. So if delta P is 0, then automatically delta X becomes infinity. So which means that only one you can measure at a time. The second is not possible at all. So that is the idea. Delta X is equal to 0, position is certain. Next, a small example I am giving here. A cricket ball of mass m 200 grams moving with a velocity 160 kilometer per hour with 0.01% uncertainty. Find uncertainty in position. 0.01% error or uncertainty. Error means uncertain. If there is error percent, means the value what you measured is not accurate. It has some range. Right, I will be waiting for your answer. Anyone? Okay, so this example I will give, and the next example you try at least. Okay. So cricket ball of mass 200 grams means that 0.2 kilograms. And what is velocity given? 160 kilometer per hour. Convert that into meter per second. 160 into 1000 by 3600. So what we write? 1600 by 36. means what we write now again, 400 by 9 meter per second. That is velocity. They only told that what is uncertainty in velocity, 0.01%, means per 100 meter per second, the uncertainty is 0.01. Then for 400 by 9 meter per second, so what is uncertainty? Calculate. That is 400 by 9 into 0.01 by 100. So that what we write now, 0.04 by 9. 0.04 by 9% per 100. Per, if velocity is 100 meter per second, then uncertainty is 0.01. Then if velocity is 400 by 9, then what is uncertainty? Identify. Then we know that delta x into delta v greater than or equal to h by 4 pi em. And boundary condition is equality. So we need to find delta x is equal to h value 6.625 into 10 power minus 34 by 4, pi value 3.14, m value 0.2 kilograms, and delta V value 0.04 by 9. So simplify and write it. That is the correct process. I think so. Some people have already did, but they made some mistakes in that again. Okay, so we are going to get 593.4 into 10 power minus 34, or 5.93 into 10 power minus 32 meters you will get, or we can say that 5.93 into 10 power minus 22 angstroms. Yes, Mr. Samik.
Sir, you said that when momentum is zero, the uncertainty point is infinity, na sir?
Yes, uncertainty
Means
condition is infinity.
yes, sir. Means the part object is continuously moving, na sir?
So momentum, uncertainty in momentum is zero, means object is continuously moving with known exact velocity. Velocity is not variable at all. 100% you are able to take exact value.
Okay, sir.
So this is the answer for the given question. Copied? Yes or no? Right. So if it is done, then I am going to give you another question. See that carefully. See that carefully. It's a very simple and logical question. Prove that electron cannot reside in nucleus mathematically. So theoretically, everyone knows that electron is revolving around nucleus. Everyone knows that electron can never be present in nucleus. And electron is always revolving around the nucleus. We know that still from the beginning of atomic structure and till now so far what we made the discussion, it is clear. But I want a small mathematical proof that electron cannot stay in the nucleus. Anyone? I will be waiting for your logical answers. I hope so. Some people have the logical brain. So try to use that and identify. Prove that electron, mathematical proof, not the theoretical, mathematical proof. Yes, Mr. Samik, continue.
Sir, I think so because electron mass is very less now, sir.
Okay.
Therefore, it doesn't reside inside the nucleus.
Okay. So any more clarity? Mathematical proof I need, man.
Mathematical, sir.
Mathematical proof I want. Yes, Mr. Heram Chandra. Let's hear the answers.
Sir, since mass of the electron is very less, then the h by 4 pi m will be very large now, sir. Sir?
Right. Medanshra?
Sir, I am thinking mass will not do any role, sir. I am thinking the velocity, sir, delta V will act something, sir. Because, sir, we can find out delta V, sir. After finding delta V, sir, if we know speed of light, sir, it will be 3 into 10 to the power 8 meters per second, sir. It is only the highest, no, sir. Means if the velocity will be more than that, we can say that it is not possible, no, sir. I am thinking we can also say like that also, sir.
Okay, right.
Sir. Can I find out delta V and say you, sir?
Yes, yes.
Thank you.
So some people already gave a mathematical idea. Right. So mathematical proof, as already one person revealed that That is enough. And let us consider, in mathematical proofs, there are two kinds of proofs we have. One is direct proof and other one is indirect proof. There are two kinds of proofs. So I'm going for the indirect proof. I'm going for the indirect proof. Direct proof means you will take the statement and you will prove it correct. Indirect proof means you will take the contradictional statement and you will prove that the contradictional statement is wrong. Direct proof we can say, but indirect we will take opposite statement and we will prove that the opposite statement is wrong so that the given is correct. So let us consider the indirect proof. Consider electron is in the nucleus. Consider electron is in the nucleus. Suppose if you are in home, so the house diameter itself means house diameter itself is the uncertainty in position. So if the electron is in the nucleus, electron can be identified within the boundary of the nucleus. So what is maximum uncertainty in position will be diameter of the nucleus. The approximate size of the nucleus we know as 10 power minus 15 meters. Approximate size of nucleus as per Rutherford's calculation, it was 10 power minus 15 meters. So uncertainty in position we will take directly as the size of nucleus itself, that is 10 power minus 15 meters. And then calculate delta V, uncertainty in velocity. If you calculate, you are getting the value as 5.8 into 10 power 8, which is velocity of light is 3 into 10 power 8. But uncertainty in velocity if electron is in the nucleus. Uncertainty in velocity if electron is found in the nucleus. So uncertainty in velocity of electron is more than the velocity of light. We know that no electron, no material particle can travel velocity of light. So the uncertainty is more than velocity of light, means original velocity will be more than this value. Original velocity will be more than this value. So velocity of electron will be more than velocity of light. So the assumption is wrong. Okay. Therefore, our assumption is wrong. Assumption is wrong. So what is the assumption we have considered? Assume. So what is the assumption made here? Consider electron is in nucleus. So electron cannot be present in the nucleus. That is the final conclusion. Yes, Mr. Heram Chandra, now you continue.
Sir, at that time, I wanted to say that since the h by 4 pi m is very high, then the uncertainty will be more than that. So since the nucleus is very small in size, then if uncertainty is that much more, then it cannot be present in the nucleus. No, sir.
Now you got clarity over the part?
Yes, sir.
Right.
I said that time I wanted to say this. Sir.
Yeah, that's okay. And this is the way of saying the answer. So the mathematical proof. So whatever we consider, the electron cannot be present in the nucleus. So direct and indirect proofs. Okay. Next. As the some mathematical forms I am giving. Some mathematical forms I am giving. You know, E is equal to mc square. So E is equal to mc means product of mass and velocity. But what we say as momentum. So E is equal to c into p. Momentum. So P is equal to E by C. So delta P is equal to delta E by C we write. Delta E by C also we can write. So just mathematical transformations remaining I am giving. So the above one copied or not? So prove that electron is not present in the nucleus. Is it over? Right. Now only mathematical conversion. See carefully. So delta X into in the place of delta P. In the place of delta P, what we can mention that? So that is delta E by C we can write. So delta E by C means we can rearrange that to delta X by C into delta E. And you know velocity is equal distance by time. Velocity is equal distance by time. So time is equal to distance by velocity. So delta T is equal delta X by C we can write. E is equal to mc square. So delta P is equal to delta E by C. Substitute that. And delta X by C is equal to delta T we can write. And so that delta E into delta T, time and energy, momentum and position there, time and energy here. Time and energy are conserved. So time and energy product is always more than or equal to h by 4 pi. This is simple conversion. So they will ask you in objective exam which of the following formula, which of the following representations are correct. Likewise. Okay. Next, another conversion I am giving you. Another conversion also I am giving you. You know, de Broglie wavelength lambda. Lambda is equal to h by mv. We know that. Lambda is equal to h by mv. And velocity is equal to h by lambda. H by m lambda we write. And differentiate that. So delta v is equal to minus. So just differentiate. The dv is equal to. So 1 by d by dx of 1 by x if you write that mean So what we write now here, minus 1 by x square, we will mention. So differentiating gives that delta V is equal to h by m is constant. So minus 1 by lambda square into delta lambda. Okay. So 1 by x, if you write a differential form, we mention that has here minus 1 by x square into dx. If you do differentiation, so minus 1 by x square into dx, the same. So 1 by lambda, we write as minus 1 by lambda square into d lambda, that is delta lambda. And you know, delta x into delta v greater than or equal to h by 4 pi m. In the place of delta v, substitute total minus 1 by lambda square into h by m into delta lambda. Delta lambda minus also there here. So h cancel, m cancel, lambda there. And so that on rearrangement, delta x into delta lambda greater than or equal to minus lambda square by 4 pi. So they will give any function, they will give any relation, delta x into delta p greater than or equal to h by 4 pi, delta x into delta v greater than or equal to h by 4 pi m, delta e into delta t greater than or equal to h by 4 pi, delta x into delta lambda is greater than or equal to lambda square minus lambda square by 4 pi. Any mathematical relation they might ask you. Any mathematical relation they might ask you. So you should be careful with that. You should be careful with that, okay? Don't forget that compulsory, the mathematical conversions will be important. Yes, over. Copying done? Yes or no? The relations all. So conceptually you can do, but the thing is they are going to ask the mathematical questions. So mathematical conversions only the most of the people will go wrong. Right. Next. I'm giving some questions, and before that, what is the importance and what is the significance of this uncertainty principle? I gave a points here, 5 points totally. You no need of copying them, just see them, just read them to get idea, only to get idea. So just read the points enough. What is the idea? So what is purpose exactly? Uncertainty principle limits the precision. Precision means that the closeness, which the two complementary properties, position and momentum, can be measured. Energy and position and angular momentum, other pairs of variables that cannot be simultaneously known. So with these two, we derived delta E into delta T greater than or equal to h by 4 pi, means that energy and time can't be measured simultaneously. And delta x and delta lambda can't be measured simultaneously likewise. For large objects, for large mass objects, uncertainty in position and velocity are insignificant. Insignificant. So the concept is very well applicable only to the microscopic bodies. Microscopic bodies. So these are the conclusions over Heisenberg principle and significance. Conclusions. Only read them, and whatever the points you need, just take them, because the concept I already gave, that is enough. But only the mathematical things we need to see, and examples over them we need to discuss. Using Bohr's atomic model, third point, we could calculate the radius of one electron system, and velocity of electron in orbit we can successfully measure as per Bohr. But as per Heisenberg principle, it is not possible to know the position or velocity with any degree of accuracy. Therefore, we describe in the position, in the place of well-defined path, we are going to give the regions, electron probability regions. Electron probability regions. So which is taken to be radius, then radius of the sphere with the electron is found 90% of the time. Means 90% chances are there to find the electron. So that we can take as radius maximum. Around the nucleus, as you are going on, where you can find the maximum chances of finding electron, at what distance it is. So to that, we can take that as a radius r. Right. These 5 points over reading. So if reading is over, then we can move on to some questions over Heisenberg concept. Heisenberg concept and de Broglie linked with Heisenberg, if there is any. Make it fast. Right. So from this Heisenberg and de Broglie, it is very clear that electron is not a particle, electron is a wave. And for the electron wave, we are going to define the probability regions instead of well-defined circular paths. Probability regions are taken. So Heisenberg proposed the quantum mechanics, and next scientist Schrödinger also proposed the quantum mechanics in the similar times of different nation people. Different nation people both are. So Heisenberg concept was confined to uncertainty, whereas Schrödinger's concept was very popular, and mostly the mathematical treatment of an electron and microscopic objects were clearly given by Schrödinger. That's why Schrodinger's concept was much popular than Heisenberg concept. Right. Next, some examples I'm giving. So let us answer these questions what I'm giving you here. So first I'm giving you 5 questions, and let us answer the 5 questions correctly. Practice the 5. I want the answers from you. 1, 2, 3, 4, 5. So uncertainty in measuring the speed of a particle is zero. If the speed of a particle is zero, then measuring the uncertainty in position will be automatically infinite. Over. So for every subtopic, the selected questions you need to practice perfectly so that you will get clarity over the concept. All five. Medansro?
All five means second one option A, sir.
Okay.
Rest three I'll do, sir.
So I want all five answers. So make them fast and give me them. Mr. Sushant, continue.
The third one, B, sir.
Third one is B.
Sir,
Okay.
all three they said, sir. Same answers. First one D, second one A, third one B.
Second one, A. Okay. Mr. Srihit?
Sir, I think second one is D, sir.
Okay.
Fourth one is A.
Okay.
Fifth one is B.
Okay.
Third one I'm not getting, sir.
Right. Uncertainty in position and momentum are equal, numerically equal. So delta x is equal delta p.
Okay, sir, understood.
Delta x is equal to delta p, which is equal to m delta v. So uncertainty principle delta x into delta p greater than or equal to h by 4 pi, we write. So that is nothing but m delta v whole square is greater than or equal to h by 4 pi. Then identify delta v as subject greater than or equal to, so 1 by m root over h by 4 pi. So 4 comes out to m, 1 by 2m into root over h by pi. Yes, over the 1, 2, 3, 4, 5, all questions. Yes or no? So only 3 people. 4 out of 93 people, 4 are saying yes and remaining no. So if no, 7, 8 means only 93 people, 11 members completed and remaining all are no only, right? Yes, Mr. Saketram. Okay. Mr. P. Sai Teja is asking remote control. Is that you? Mr. P. Sai Teja, respond.
Yes, sir.
Is that you are asking the remote access?
No, sir.
Then are you seeing the display?
Yes, sir, I'm seeing.
Who is that person? Not you?
No, sir.
Right. So next I'm giving 5 more questions and I'm waiting for your answers again. So consider the de Broglie consider an electron in the nth orbit of hydrogen atom in Bohr's model. So circumference of the orbit can be expressed as directly what we say n lambda. Directly what we say n lambda. And this is already repeated question. No, repeated model, but opposite. Means different model again. So a particle x moving with velocity has de Broglie wavelength 1. And if the particle y has mass 25% of x and velocity 75% of x, good. So let's finish the questions and tell me that if it is done, then I can move to Schrodinger wave equation if you complete this 5 correctly. So we can move on to the Schrodinger wave equation right now. Schrodinger wave equation we will move on to if you finish these 5 questions correctly. Mr. Srihit ready?
Sir, seventh one, option B, sir.
Seventh one?
Option B.
Okay. Mr. Sushant? Okay, Mr. Sai Teja?
Sir, eighth one D, sir.
Eighth one D. Okay. So Lasya, respond if you are there in class. So till now I searched your name, but I didn't find, and just now I
No,
got.
sir, I logged in with another device actually, and actually those were in two devices, and I didn't keep my name. And mom called me now. She said that you're. That's why I wasn't. And in that system, I was speaking, but I couldn't. Even in the before days, that's what the reason I unmuted. But when I was speaking, the sound wasn't audible for you.
So whenever you log in any device, keep the name as it is. Don't change the name, okay?
Okay, sir.
So have you practiced all these questions over? Practice?
Yes, sir, but
What is the answers for them? So you didn't even answer the single question
I
till
didn't.
now
I
so
mean,
far.
I was like.
So I want some quick response, okay? Yes. Mr. B. Varun, B. Tarun. I kept you in waiting room because you didn't turn on the mic.
Power answer, power answer. Eighth one D, sir. Ninth one B.
So why you switched off your mics? Means turned off the mics then, both of you?
Power answer.
Power gone, okay.
Eighth one D, ninth one B. B.
Ninth one B, okay.
That's it, sir.
Right. Mr. Sai Teja?
Sir, same answer, sir.
Tenth one?
Doing, sir. 1 minute.
Nothing to do there. Nothing to do there. Medhan Shrav?
I wanted to say, sir, but I wanted to say the answer, sir. I got everything same.
Right. So in these 10 questions, if anyone have doubt, particularly you can ask, I will explain. Get clarity. Get clarity. If any doubt is there, ask me, I will explain. Mr. Rahul?
Please explain fourth one, sir.
So what is the velocity given, Mr. Rahul?
10 to the power of minus 6 centimeter per second, sir.
Okay. Then what is uncertainty in velocity?
100. 1 minute, sir, I will tell.
0.0001% means that per 100, the uncertainty is 0.0001. Okay. Then per 10 power minus 6, what is the value? So this will be delta V. Okay. Do you understand that?
Yes, sir.
So 10 power minus 6 into 0.0001 by 100, that is delta V. And all were given in CGS systems only, but they are asking in MK system answer.
10 to the power of minus 12.
They gave delta V. How much you got?
10 to the power of minus 12, sir.
So 10 power minus 4 minus 10, so minus 12. So delta V is 10 power minus 12. That is centimeter per second. But in meter per second, 10 power minus 14 meter per second. Okay.
Yes, sir.
Then what is mass? M is equal to
10 power of minus 10 grams, sir.
10 power minus 10 grams means 10 power minus 13 kilograms. Understood now?
Yes, sir. Then we
And now find the uncertainty potential.
Sir, but what is given diameter, sir, there?
That is unnecessary for us.
Yes, sir.
Understood that? Sometimes extra data will be given. We don't want that. And don't try to use every detail given in question. It is not required.
Okay.
Any more? So correct the question answer. If there is wrong in that, correct it. Any more doubts you have in question numbers 1 to 10? So are you perfect about this 10? Understood all the questions, 10 questions given? At least say a response yes or no. I'm asking you openly so that problem solving skills and strategies will be elevated if you practice the question. So if you have any doubt, you can ask. If you have any doubt, you can ask. I'm asking freely again. Right. Mr. Medhanshro, continue.
Sir, can you please scroll down once, sir?
1 second. Yes.
Yes, sir. This seventh one, sir, can you give me a just idea, sir? I'll do on my own, sir.
A particle X moving with velocity. Right? If velocity is given, what is de Broglie wavelength?
Okay, sir.
Lambda is equal to h by mv. Okay.
Yes, sir.
Then what is lambda? They give 1. Then what is
1 Armstrong units.
velocity will be h by m.
Yes, sir.
So velocity of x is h by m. Keep that.
Yes, sir.
Next, particle y has mass 25% of x.
Okay, sir. Means 25% of X.
Means m by 4.
Yes, sir. For 100, 125, how much like that only?
Correctly, m by 4. Mass of
Yes, sir.
y
M by
is
4.
m by 4. Okay. And
Yes,
the
sir.
velocity is what? 75% of x. Means 3 by 4v.
Yes, sir.
3 by 4v means what we write? 3 by 4 into h by m.
Yes, sir. 3 by 4 H by M.
Understood? Then what
Yes,
is
sir.
lambda?
Okay, sir. Understood. Just substituting in the
All
equation we get
substitution.
the. Okay, sir.
Simplifications only.
Thank you, sir.
Mr. Heram Chandra?
Sir, mass and velocity of y I took as m by 4 and 3v by 4, sir.
Again?
Mass and velocity of y is I took as m by 4 and 3v by 4, sir.
Okay.
Sir, and I did lambda y by lambda x, sir.
Yes.
So then I'm getting different answers, sir.
So what answer you are getting?
I'm getting 2.66 Armstrongs.
Okay.
So it is
Okay, let
synthesis
us check
mistake.
it. Yeah, that's okay. Let us check it. If you have ambiguity and if you have confusion, let us get clarity. Solution. So particle mass of x I am taking as m, and mass, I mean velocity of x I am taking as v. Let me consider. And so that mass of y is 1 by 4m and velocity of y is 3 by 4v. 3 by 4v. Okay, na? Then lambda of x by lambda of y is equal to h by mv for x whole divided by h by mv for y. Right. Yes, Mr. Hiram Chandra.
I got it, sir. I did calculation mistakes. Sorry, sir.
So verify the calculation at least twice if you have any doubt, okay? And make it correct and perfectly. So is that understood now? Right. So if you are clear about this, let us check. And next, I am going to give you 1 second. It is not responding. So I'm going to give you 5 more questions and identify along with the de Broglie wavelength questions there. Just take the maximum it takes every question 1 minute. Maximum it takes every question 1 minute, not more than that. So mass of a particle of 1 milligram velocity, what should be the wavelength? Okay, if you want to get practice them, just take the screenshots and practice them in evening time when you are free. In evening time when you are free, do that, no problem. Next, so 4 and 5. Now I want answers for 4 and 5 right now. 4 and 5, right now I want answers. 1, 2, 3, you can practice in free time, not a problem. So I want answers for these two questions, 4 and 5 right now. I'm waiting for your responses. So 4 people want to say, Advait? Mr. Advait? No.
Sir, is the answer second option for fourth question?
You say first I will write. Second option you are saying?
Yes, sir.
Okay, then 5.
I didn't solve now, so I'll solve.
Next, Mr. Suraj.
Fourth option 2 only, sir.
Option?
Option 2.
Okay, okay, right.
Yes, taking good, sir.
And I want the answer for the next question also. Medhan Shroff?
Sir, I think for fifth one it will be same, sir. 32 into 10 to the power 5.
32 into 10 power 5. Okay.
Yes, sir. Because it will be same only, sir.
Okay. Advait?
Sir, I'm getting the same value for this one.
Yeah, that's okay. So uncertainty in position is the same as delta X of helium atom. So delta P of electron is 32 into 10 power 5. Then delta P in helium atom will be. So delta P of electron is given. Uncertainty in position is the same. So that automatically delta X is the same, means delta P also should be same. So delta X of electron is the same as the delta X of helium atom. Delta X of helium atom, which is nothing but h by 4 pi m delta V. Here also h by 4 pi m delta V. For electron is equal to for helium atom. For helium atom. So h is a constant for everyone. 4 pi is a constant for everyone. Then what we write now here, so delta V of helium, m into delta V of helium is equal to m into delta V of electron. Yes, Mr. Heramchandra.
So second option and yes, 32 into 10 power 5.
Same answer you are getting, 32 into 10 power 5. Right. So that is the idea. M into delta V is what we say directly, momentum. They're asking momentum only. So delta P of helium is equal to delta P of electron. So directly we can write the same value, 32 into 10 power 5. That is the answer. Now keep heading that Schrodinger wave equation. Schrodinger wave equation. Medhanshu?
Sir, can we say delta P will be same for all, sir? Means like, can we say like that, sir?
No, you cannot say. The condition is there. If delta X is the same, then delta P will be same, because delta X into delta P should be more than or equal to h by 4 pi. Okay?
Yes, sir. Yes,
Yes,
sir.
boundary
Means
is the
if
same.
condition satisfies, we can confirm.
Yes, it is.
Yes, sir. Thank you, sir.
So next, Schrodinger wave equation. Yes, continue.
Sir, both masses will differ, no sir, electron and helium.
Yes, they are differ.
Then how it will be equal, sir? Velocity. Sorry, momentum.
Momentum is what actually, can you tell?
Mass into velocity.
Velocity. So mass is different and velocity also different, okay? See, to avoid the confusion to you, I am giving the simple logic. The logic is they only told delta X of electron is equal to delta X of helium atom, right?
Yes, sir.
And for anything, delta X into delta P greater than or equal to h by 4 pi.
Yes, sir.
So if delta X is same, automatically delta P value also should be same or not, because the product should be h by 4 pi.
Okay, sir. Okay, sir. Okay, sir. Thank you.
If mass is variable, accordingly velocity is variable, and so that the product will be same. Next, Schrodinger wave equation. Consider de Broglie's concept for understanding the Schrodinger wave equation, and as per de Broglie, it was clear that electron is a wave. Electron is a wave. And as most of the people belong to the IIT Foundation backgrounds, you people have already had idea of wave mechanics. And so that in wave mechanics, the electron, I mean, simply if you are taking wave, so for the amplitude, we write amplitude of the wave is equal to sine omega t plus pi or cos omega t plus pi, some mathematical formula we will take. The same thing here. By taking electron is a wave. Schrodinger wave equation totally depends on electron is a wave. Assume that it is a wave. Assume that it is a wave. Okay, and by taking that electron wave, the amplitude of electron wave, the amplitude function is represented with a letter psi, Greek letter psi we use for electron wave. The amplitude function is expressed as psi. Psi, the way of writing it is this one, psi. So reading is psi, but the spell is psi. So P is silent, psi we use that. So amplitude function of the electron wave, is commonly taken as a psi. As it is the amplitude function, so we can assume that it has some mathematical part, because we are going to derive the wave equation. Means for electron wave, the amplitude function, we will derive that second order wave equation. We will take. So for electron wave, the amplitude function is expressed as psi. And its physical meaning we will discuss later on. Its physical meaning is different. We will discuss that again. So psi is called a wave function. Psi is called a wave function, or wave function of electron wave. Wave function of electron wave, we can say that. And psi can be mathematically represented as a sine 2 pi x by lambda. A sine 2 pi x by lambda, as it is amplitude function where capital A is the constant here, and sine 2 pi x by lambda x is the differential x-axis, and lambda is the wavelength of electron wave. A sine 2 pi x by lambda. So psi is equal to a sine 2 pi x by lambda, we can imagine, and we can take that. And you know, d by dx of sine x, d by dx of sine x is cos x, but d by dx of sine ax, a into cos ax we need to write. So derive the expression. D psi is equal to d by dx of psi. D by dx of psi. Differentiate the expression. So on differentiation, d psi by dx is equal to a cos 2 pi x by lambda into 2 pi by lambda, because the constant also again you need to write. So d by dx of sin ax is equal to a into cos ax. A is 2 pi by lambda. So a cos 2 pi x by lambda into 2 pi by lambda. Now differentiate that again. If you differentiate that again, so d by dx of cos x, is equal to minus sin x. D by dx of cos x is minus sin x. So again derive that second order form, means 2 times derivation, 2 times differentiation. First differentiation gives 2 pi by lambda a cos 2 pi x by lambda. And second time differentiation gives minus 4 pi square by lambda square into a sin 2 pi x by lambda. So from 1, what is a sin 2 pi x by lambda we write? From 1, what we can write as a sin 2 pi x by lambda as psi directly. So d square psi by dx square is equal to minus 4 pi square by lambda square into psi. Just differentiation 2 times. S over. So first derivative is giving that 2 pi by lambda a cos by x by lambda. Second derivative is giving that minus 4 pi square by lambda square into psi. Over. So this is along x-axis, differentiation of the wave function, the amplitude function along x-axis. And you need to take the coordinate axis yz also. But before that, we do a small mathematical treatment for lambda square, as we have the term of lambda. You know lambda is equal to h by mv. Lambda is equal to h by mv. And from that, lambda square we will express. Is that copied? Yes or no? Not yet, okay. Right. Now, the remaining mathematical conversions also I'm showing you that as lambda is equal to h by mv, we know. And take that lambda square is equal to h square by m square v square. And you know kinetic energy formula is half mv square. Kinetic energy formula half mv square. So half m square v square by m we write. So in the place of m square v square, substitute that h square by lambda square here. In the place of m square v square, in the expression, substitute h square by lambda square. What you get in from 3. And you know kinetic energy expression. And what is the total energy expression here? Kinetic energy plus potential energy. So if kinetic energy is equal to total minus potential, total energy is E and potential energy is V. So E minus V we need to write. E minus V we need to write. So total from this 5 unit write lambda square 1 by lambda square as subject and substitute into. From this 5 write 1 by lambda square as subject and substitute 1 by lambda square into. That is the thing you need to do. In exam, you no need to worry about the derivation. You no need to worry about the derivation. No one will ask you. Only for understanding. So how did we get and where did we get? Only to give that I gave it. Okay. So E minus V is equal to half into H square by M lambda square we write. And from this, what we write as 1 by lambda square is equal to 2M into E minus V by H square. 2M into E minus V by H square is equal to 1 by lambda square. That you need to substitute into expression 2. And this is the final form you will get. So d square by dx square is equal to d square psi by dx square is equal to 8 pi square m by h square into e minus v into psi. This is along x-axis. This is along x-axis. This is along x-axis. Okay. So by taking three coordinate axes, so this is the simple final form of equation we write, because in exam they are going to ask you this equation, not the above derivation. Derivation is not required, only for matter of understanding I give. So this is the final equation you need to understand. Dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square into e minus v into psi is equal to 0. So three coordinate axis x, y, z, the psi is being undergone differentiation 2 times, double derivative, and 8 pi square m by h square into E minus V, total energy minus potential energy into psi is equal to 0. So this is the final equation for Schrodinger wave equation, final form. So the above derivation is not required to you. Only this equation you should remember, because they will ask you which of the following is the correct representation for Schrodinger wave equation. They will ask you. Is copied? Yes or no? So final form of equation, this is the equation you should remember. So don't think more. So from where it came and what is its story, that is not required right now, because that is beyond your scope.